What did James Webb see at the very edge of the universe? The answer will shock you. But before we begin this journey, make sure to subscribe my channel, Star Sky Science, for more amazing space mysteries for thousands of years. Humanity has looked at the night sky and wondered, where did we come from? How did the universe begin? And what lies beyond the stars we see? These questions have followed us since the dawn of civilization. Every culture, every generation, has searched for answers written in the heavens. In modern times, our greatest tool to explore the cosmos has been the telescope, from Galileo's first small lens to the giant observatories on mountaintops, and then the famous Hubble Space Telescope that gave us breathtaking images of galaxies and nebulae. But even Hubble had its limits. It could only see visible light, while the oldest secrets of the universe were hidden in invisible infrared light. The faint glow of the very first stars, the chemical fingerprints of alien planets, the whispers of the cosmos from billions of years ago, all of this remained out of reach. Scientists knew they needed a new eye in the sky, a telescope more powerful than anything ever built, one that could see not just across space, but back in time, to the very dawn of the universe. This dream became what was first called the Next Generation Space Telescope. Later, it was renamed in honor of James E. Webb, the NASA administrator who led the Apollo program and guided humanity to the moon. Naming it after him was symbolic. This too was a giant leap. The idea was bold, but building it was harder than anyone expected. The project officially began in 1996. At first, the plan was simple: launch by 2007, with a budget of $500 million. But science is never simple. The more scientists dreamed, the more ambitious the telescope became. New goals were added, designs grew more complex, and costs climbed higher. By 2005, the budget had already soared to $5 billion. By 2011, Congress nearly canceled the project altogether. But astronomers fought back. They knew this telescope would change everything. And so, against all odds, the mission survived. What made it so difficult? The James Webb Space Telescope was unlike anything built before. Its golden mirror had to be 6.5 meters wide, more than twice the size of Hubble's. It had to stay colder than -220 degrees Celsius, otherwise faint cosmic light would be drowned in heat. To make this possible, it needed a sunshield the size of a tennis court, made of 5 paper-thin layers of special material. And because no rocket on Earth was big enough, the telescope had to fold like origami inside the rocket and then unfold perfectly once in space. The mirror itself was made of beryllium, coated with a thin layer of gold to reflect infrared light. Each of the 18 segments could move with incredible precision, adjusting themselves by tiny fractions of a hair's width. The engineering was breathtaking, but it also meant that one mistake could doom the entire mission. Finally, on December 25, 2021, after 25 years of work and $10 billion spent, James Webb launched aboard an Ariane 5 rocket from French Guiana. For humanity, it was the greatest Christmas gift ever given. The launch was perfect, but the hardest part was just beginning. Over the next 30 days, Webb traveled 1.5 million kilometers away from Earth to its new home at the second Lagrange point. Along the way, it had to slowly unfold its sunshield, its mirrors, and its instruments. Astronomers called this the 29 days of terror. There were hundreds of single points of failure. If even one of them failed, the telescope would be lost forever. But step by step, everything worked. Like a golden flower opening in the darkness, James Webb unfolded itself. By January 2022, it had reached its orbit at L2, safe and stable, ready to begin its mission. When the first images came back in July 2022, they were more than just pictures. They were glimpses of the oldest light in the universe. Galaxies forming billions of years ago, stars shining for the first time, entire cosmic histories unfolding before our eyes. Many scientists who had worked for decades wept when they saw those images. For them, and for all of us, James Webb was not just a machine, it was a time machine, a window into our origins, and proof of what humanity can achieve when we dare to dream beyond our limits. But this was only the beginning. The true power of James Webb was still waiting to be revealed. The mysteries at the edge of the universe were about to unfold. and ancient that they existed when the universe was less than 1 billion years old. For the first time, humanity was seeing the universe as it appeared at the dawn of time. Among the most extraordinary discoveries was the detection of galaxies that formed much earlier than anyone thought possible. Astronomers had believed that galaxies needed hundreds of millions of years after the Big Bang to take shape. But Webb found fully formed galaxies shining brightly just a few 100 million years after creation itself. This discovery shook the foundations of cosmology. If galaxies formed this quickly, then perhaps the early universe was more efficient at creating stars and structures than scientists had ever imagined. The question became urgent: are our theories about the early universe incomplete? Webb has forced us to rethink how everything began. But Webb is not only looking backward in time, it is also turning its gaze toward distant worlds orbiting other stars, exoplanets. For years, astronomers have discovered thousands of these planets, but they remained little more than points of light. Webb changed that by carefully measuring the faint dimming of starlight as a planet passes in front of its star. Webb can analyze the thin layer of atmosphere surrounding it. In 2022, Webb detected water vapor in the atmosphere of a distant gas giant planet. Later, it identified carbon dioxide, methane, and even signs of complex clouds in other exoplanets. For the first time, humanity is studying the skies of alien worlds hundreds of light years away. The implications are enormous. Somewhere out there, in the darkness, Webb may detect the chemical fingerprints of life. One of its most breathtaking images came from the Carina Nebula. This massive cloud of gas and dust, invisible in many wavelengths of light, was revealed in astonishing detail. Towering cliffs of dust, sculpted by powerful stellar winds, glowed with newborn stars. Webb captured not just the beauty of the cosmos but its raw power, showing us stars being born in their cradles of gas. For scientists, this was more than an image. It was direct evidence of how stars form, grow, and shape the galaxies around them. For the public, it was a reminder that the universe is alive, constantly creating, constantly evolving. Webb has also turned its eye toward the monstrous hearts of galaxies, black holes. In one case, it studied a galaxy more than 13 billion light-years away and found evidence of a supermassive black hole already in place at that early time. This discovery was shocking. How could something so massive exist so soon after the Big Bang? Scientists are now debating whether black holes grew far faster than expected, or whether they formed from entirely different processes than we thought. Each answer Webb provides seems to raise even deeper questions. The telescope has also reshaped our view of our own cosmic neighborhood. It has studied planets and moons in our solar system with a clarity never seen before. It revealed the delicate rings of Neptune, glowing like a cosmic jewel. It imaged Jupiter in detail, capturing not only its storms and auroras but also the faint traces of its thin rings and distant moons. Even the icy giants at the edge of our solar system are no longer strangers. Webb has shown us that the universe is not just vast and ancient but also deeply connected, from our own backyard to the furthest galaxies. But perhaps the most haunting images Webb has delivered are of galaxy collisions. Across the universe, galaxies are constantly merging, pulled together by the invisible force of gravity. Where Hubble once showed fuzzy shapes, Webb now reveals intricate webs of stars, dust, and gas being torn apart and reformed. These cosmic collisions are not rare accidents. They are the engines that build larger galaxies, including our own Milky Way. Billions of years from now, our galaxy will collide with Andromeda, and the night sky will glow with streams of stars. Through Webb, we are watching our own future written in the stars. The telescope has even shed light on dark matter, the mysterious substance that makes up most of the universe but cannot be seen directly. By observing the bending of light around massive galaxy clusters, Webb helps map where invisible matter lies. These gravitational lenses not only reveal the hidden structure of the cosmos but also magnify galaxies even further away. Acts like natural telescopes in space. In this way, Webb uses the universe itself as a tool, peering deeper into time than ever before. And yet, despite all these breakthroughs, Webb's greatest promise may still lie ahead. Every observation it makes is carefully planned, but the most exciting discoveries often come by surprise. Scientists believe Webb may stumble upon objects and phenomena we have not even imagined, perhaps strange types of stars, new classes of planets, or even signs of life. The edge of the universe is not a boundary, but an invitation. With Webb, we are just beginning to answer questions as old as humanity itself. Where did we come from? How did the first galaxies form? And are we alone in this vast expanse? The answers are still unfolding. Each day, Webb sends back new data, each image more stunning than the last. It is as if the universe has been waiting billions of years for us to finally build a machine capable of hearing its voice. And now, for the first time, we are listening. The James Webb Space Telescope has only just begun its journey, and yet it has already transformed our vision of the universe. But what lies ahead may be even more extraordinary. Webb is not just a machine for taking pictures. It is an observatory, designed to keep searching, to keep revealing, for decades to come. Scientists believe that the most revolutionary discoveries will not come from the questions we already know to ask, but from the mysteries we cannot yet imagine. This is why the future of Webb is filled with both promise and wonder. In the coming years, Webb will dedicate much of its time to studying the first galaxies that ever existed. These faint smudges of light, invisible to almost every other telescope, may hold the key to understanding how the universe transitioned from darkness to light. By examining their structures, Webb will allow astronomers to trace how gas and dust assembled into stars, and how stars gathered into galaxies. Over time, researchers expect Webb to build a kind of cosmic family album, a step-by-step record of how the first sparks of light grew into the universe we see today. This will not just confirm theories. It may rewrite them entirely. One of Webb's most ambitious goals is the search for life. Already, it has analyzed the atmospheres of distant exoplanets, but the real breakthrough would come if it detects what scientists call biosignatures, the chemical fingerprints of living processes. Imagine a world where the air contains oxygen alongside methane, or where unusual gases are present that cannot easily be explained by geology alone. Such a discovery would not be proof of life, but it would be the strongest hint humanity has ever received that we are not alone. Astronomers expect Webb to spend the next decade focusing on Earth-like planets around small, cool stars. These worlds, orbiting close to their suns, could be within Webb's reach. And if life exists there, Webb may be the first to sense its presence. The telescope will also continue to turn its gaze on the mysteries of black holes. So far, it has found black holes far larger and older than expected. But the real puzzle lies in understanding how these monsters grew so quickly. In the next 10 years, Webb will search the deep universe for more examples, building a timeline of black hole growth from the earliest days of creation until now. If astronomers can solve this puzzle, they may also understand how galaxies themselves formed and evolved, since the fates of galaxies and their central black holes are deeply linked. Closer to home, Webb will revolutionize our knowledge of the outer solar system. Its powerful infrared vision can penetrate the icy atmospheres of Uranus and Neptune, revealing details of their weather systems, ring structures, and moons. These worlds, still largely mysterious, may turn out to be more dynamic than we imagined. Webb is also capable of studying comets and asteroids, the leftover building blocks of our solar system. By analyzing their compositions, scientists hope to uncover the story of how Earth itself formed and how water and organic molecules may have arrived here billions of years ago. In other words, Webb may help explain not only how the universe began, but also how life began on Earth. Perhaps the most thrilling possibility is that Webb will discover something completely unexpected. Every great telescope in history has surprised us. Hubble revealed dark energy, the mysterious force accelerating the expansion of the universe, a phenomenon no one had predicted. Many astronomers believe Webb will stumble upon its own revolutionary surprise, something that changes physics itself. It could be a new type of star, a strange exotic planet, or even a phenomenon that forces us to rethink the very laws of nature. We cannot predict what it will be, but we can be certain that Webb's sensitivity and reach will open doors that have never before existed. Over the next 2 decades, Webb will work hand in hand with other observatories, creating a golden age of discovery. The Hubble Space Telescope is still active, and when combined with Webb's infrared vision, the two telescopes provide a complete view of the universe in both visible and invisible light. In the future, new telescopes, like the Roman Space Telescope and the extremely large telescope on Earth, will join this cosmic partnership. Together, they will provide a multi-layered view of space, each complementing the other, and Webb will stand at the center of this new scientific era. But beyond science, Webb's legacy will be cultural and human. Its golden mirrors are not just instruments, they are symbols of curiosity, ambition, and unity. Built by thousands of scientists, engineers, and dreamers across many countries, Webb represents what humanity can achieve when it works together. Over the next 20 years, children who see Webb's images of galaxies, nebulae, and alien worlds will grow up with a deeper sense of connection to the universe. They may become the next explorers, the next scientists, the next storytellers who carry our journey even further. And so, as Webb continues its mission, we find ourselves standing at the edge of an unfolding story. Every day brings new data, new revelations, new hints of what is still to come. The telescope may last 10, 15, or even 20 years, but its discoveries will echo for centuries. One day, when future generations look back at this moment, they may say that the story of the universe changed when Webb first opened its eyes. For now, we wait, we watch, and we wonder what secrets it will reveal next. We began with a simple question. What did the James Webb Space Telescope see at the edge of the universe? And along the way, we discovered that Webb has given us more than just pictures. It has given us a new way of seeing ourselves. Every faint galaxy, every newborn star, every alien world it reveals is a reminder that we are part of something vast, something ancient, something still unfolding. For billions of years, the universe has been expanding, changing, and creating, and now, for the very first time, one small species on a tiny blue planet is able to look back at that history and witness its beginning. Webb is not just a telescope, it is a time machine, a bridge between what once was and what is yet to come. Maybe the most powerful discovery is not out there in the stars, but in here, in us. The wonder, the curiosity, the desire to know more, that is what truly connects humanity to the universe. Webb's golden mirrors are like eyes, but they are also like a reflection, showing us what we can achieve when we dare to dream. So as we close this journey, remember, every image from Webb is not just science, it is history in the making. Someday, people may look back and say this was the moment humanity truly began to understand the cosmos, and you are alive to witness it. That is a gift beyond measure. If this journey through space inspired you, then join us again, because there are countless more mysteries waiting to be told. Subscribe to the channel Star Sky Science, share this video with others who love the universe, and let's continue exploring the unknown together. After all, the universe is still expanding, and so is our curiosity. Until next time, keep looking up, because the story of the stars is also the story of us.